Welcome everyone this afternoon for this session. The session is deploying multi-agent systems in production at scale. I am Puneet Narang. I'm part of EYGDS. I lead the FS side, like mainly I work on the AI solutions. I lead a team of data scientists. And Anurag, who's my colleague, he's part of our team. And he's also a senior data scientist in our team. And he also is working on agentic and some of the generative AI applications. So I hope everybody is, I think it's post-lunch, so I hope everybody is not feeling sleepy. We will try to make it as interesting as possible. It will be slightly tech-heavy. We have tried putting a lot of content on, to ensure that you guys get the real, considerations, what should be done on the productionization part. I think we'll go to the next slide. So we are at an inflection point in year 2025. You might have seen most of the organizations are now thinking about adopting agentic AI. And this year, if you look at most of the corporates, enterprises, they want to leverage agentic AI and multi-agent systems for automating their applications or processes, like making autonomous decisions and transforming their businesses. So this year is going to be very critical. But what is happening is the prototyping, as you know, most of the clients whom we speak to, they are right now in the lab phase. They are just experimenting. They're doing POCs, pilots, right? They have still yet to move to production because this has been a very new system. Like they have recently come, right, agentic AI, and everybody's learning, right? Frameworks are evolving, and everything, or the tooling is evolving. Everything is evolving right now, okay? And if I were to, on a lighter note, give a very, I just want to make the mood lighter, and like compare POC pilot versus a production is like, I hope everybody has dated when you did, right? What you have big plans. You think that you will go to Mumbai, Worli, you will have a 5-bedroom hall. Everything looks picture perfect. You want to do things. You want to go honeymoon for somewhere, right? In Switzerland, and you have a lot of dreams, right? And that you start. But the moment your marriage comes and you have commitment, right? You have hard facts. You think that, then you realize that you have limited money in hand. You have you have your there are certain things that you have to, constraints are there, right? You have to, you start hitting the hard facts, and that's where you realize that, and you get grounded, right, on what should be with the real, what you would want to do is in the real moment, right? That's where same thing I wanted to give you as an analogy. With this, that is where we talked about that making the production is the real thing because everybody's innovating. The algorithms are there. But the key thing is about scaling, right? If you're able to scale, if you're able to make it successful in the enterprises, you see more adoption. And that's where we'll see the success. So that's our key message that I'm going to focus on. This slide is just put for context, because I think already in this whole, there are so many sessions happening on what is multi-agents. I don't think I need to introduce what is multi-agent systems. And like everybody knows what is X-supervisor, planning, agent, right? All these tools, et cetera, everybody is aware of. So I'm not going to cover this in details because my core focus is on productionizing AI. But what I want to say is that agentic systems, if you look at defining, these are autonomous and adaptable systems, which are able to, autonomously able to take decisions. They can automate tasks. They can course correct themselves based on the feedback, based on the context that they're getting, and they're able to adapt themselves. That is what is the agentic systems. And if you look at the example that is given on project management agent, some scenario they've given, just think through in the future. Analogy is that in future you will see projects getting smoothly executed. May or may not be, but this is the vision that everybody has, that project manager agent will work with a department agent, and they will all work together seamlessly, hand over tasks from each other without wasting time, without going for cigarettes and without wasting time, and things will get smoothly done. That's what the vision, I think, of the multi-agent system is. They want to automate the process in the future. I don't want to spend more time because this is more like a very high-level thing. Let's go to next slide. Okay, so this is where the real thing starts. So when you're trying to make when you're trying to scale up your multi-agent systems, you will encounter, and I don't know how many of you have really gone into production. Anybody has put any multi-agent systems in production? Any question? Anybody in the audience has taken it through production for any enterprises? Oh, great. Okay. So, okay, there are 2, 3 people. Okay. So the people are still evolving. So it's still evolving. So, and no surprise that only 2 people have, or maybe very few people. So if you look at the challenges that you face, is that the frameworks are still evolving. There are limits in the frameworks, no matter how mature they are in terms of number of agents that you can add, the number of API calls they can do, right? And the moment you start adding more agents, there's an issue of context management, state management, because those issues start hitting, right? So it is not easy to do that. And also second is a selection of agent pattern, which agent pattern to select, which frameworks to select is very important activity. And if you select the wrong one, you might again face up challenges, and then you might again have to start from the ground zero, because the design is not right, then you will again have challenges. Same thing in terms of the agent collaborations, because in multi-agent systems, there are supervisor agent talking to other agent. They all have rules, right? And there's also in the rules, and many times when the agents are coordinating with each other, there's communication happening. They might go into infinite loop. There might be issues where the right context or state is not forwarded to the other, passed to the other agent. That may go into agent may not be able to answer correctly. So these issues are practical and do come. Like same thing with tooling. So what happens is the agents have toolings with them. The agents call tooling, right? Sometimes if the arguments are not properly passed, it might not be able to evoke the right, it might not be able to execute the correct. Like if you are expecting, for example, JSON output, but what we've seen from the practical experience is that, out of 10 times, maybe 1 or 2 times it will happen. If you're not fine-tuned your prompts, or if you're not done the right way of fine-tuning, it will not give the right JSON format output. And if the right JSON format output is not there, for example, in then the upstream or the downstream agents or the tools will not be able to take action further, right? Because it has not got the format that it expected. So it might fail. There are other issues also, like when you're trying to evoke tools or the function calling or whatever, then if the API calling is not asynchronous, and you just did a POC, and you had tools, agents giving tasks to the, to the sub-agents, and sub-agents giving it to the tools. One API is still being called, and it's taking 3-4 minutes. In the meanwhile, because the system's autonomous, there's another call, it will find out the agent is busy. The first call is still not, right, synchronous. So you have to think through asynchronous actions. So those things are very important considerations and need to be evaluated. Same thing if you look at in the, when you are having a role, for example, each agent, one is role. The second is you also have agents play some, you have to select the agent, what agent, like how it will perform, what action. Like for example, like what you call agentic control, we scale it, control toolkit. So whether it's behaving like a reflection agent, whether it's behaving like a React agent. So all that definitions and the prompts, and it has to be grounded. If you don't put that properly, it may also have an issues. So you have to be very careful. And other thing is that every time when you're calling, you have to also think through error handling. You have to think through what is a fallback plan. And these are the things which in the POCs you would not do. But when you start doing in the production, you realize this challenges come. Other is like if you are trying to scale up like to a few thousand users, and users are there, whether whether you have to, for example, Microsoft said PTUs or tokens per limit, whether that's getting exceeded, you might need to think through a load balancer. There are a lot of other things in scaling when you're doing vertical scaling or horizontal scaling, which I'm going to cover, which you also have to think through, because those things will not come when you're doing a small POCs, because in POCs you are just doing 10, 20 users. That time, those things will not be of that much consideration. But the moment you scale up, these things start popping up, and you start having issues. Okay, so this takes us to the next slide. This is what this is translating from the last challenges. So this talks about what could be the key production considerations when you're going to implement multi-agent systems in production. What are the different considerations? What all you should think through? right? I think you have to first, and the foremost thing is you have to start with the design part. If the design is not right, and you've not selected right patterns, if you've not selected right tooling, and you're not thought through the use case in detail, whether the use case requires a role-based agents or there's a task-based automation, then the first step itself is wrong, right? We will not be able to move ahead, and you might be with the wrong start. So you have to design this properly, okay? Once you've done that, you know to think through the memory management. Memory management is also very critical because memory, like it helps you in the like the context management in the near term. If you're having any conversation the multi-agent system is having, all the recent conversation, it maintains its own like a snapshot of the historical summary of the conversation, through which it is able to get the context. So think it like a sticky notes on the recent conversation. If you in your room, if you put a recent conversation, sticky notes is something which is called a short-term memory. And the long-term memory is about, I'm going to cover that in more details, look like the episodic memory, semantic memory, how over the period of time agent can improve, how can it have a flash memory. So all those things you have to plan properly, because when you're going to do this in the production, these things becomes very critical. Because if you're not factored and properly thought through that, and also in the current system, some of the frameworks which are available in the market may give you option to fine-tune memory up to a level. Some of them will not give you, okay? Because they have just come in the market, there are limited configuration options available. So depending on the use case, you need to really think through how granular level of memory management you want. And that decision has to be taken. Next is on the evaluation. I think evaluation is very important, because if you don't evaluate your system or the LLM, like the whole agentic flow, you will not be able to understand, and unless you go through a couple of iterations, you will never be able to get to a right consistent output. So evaluation is very key. This is the whole topic I think we're going to cover, so I'm not going to spend too much of time here. Then there's a design pattern I've covered, I think. Then the user interaction, how the UI should be designed, and then the observability and guardrails. Observability is also very important, because you want to monitor what is happening in each level, whether one agent is handing over to second agent or not, task getting executed. You want to know what is happening behind the scenes, so that if there are any errors, you should be able to fine-tune your system and fix them. And the same thing is with the guardrails. The guardrails are very important, because if you don't have guardrails, you are potentially exposing yourself to the security risks of your system. And multi-agent system, because they interact a lot with external, internal environments, they make API calls, they can go to internet, because for tooling, you have to be extra cautious in what you do. Okay, so this covers very high level the solution design. When you're designing the solution, you have to look through different considerations. So starting with, if you look at when you get the requirements from the client, you have to first see whether it's a single-step process or a multi-sequence process. It is a role-based or non-role-based process, what you are going to automate, right? Whether it's a sequence of tasks or how much level of autonomy is required. If you don't have clarity, you may end up with, doing wrong selections for the next phase, which is a design consideration. So this second-level design considerations helps you select the right frameworks, right tooling, right patterns. So you need to know level of autonomy and whether you need planning, whether it's deterministic process, what it is. And that your selection of whether you use Q.AI or all the other frameworks is going to very strongly depend upon that. Because some systems like Q.AI or LangGraph are very good in the role-based. There are some frameworks which are very good in the sequence-based. So these decisions are very important. Then the network pattern. What level of hierarchy? Is it going to be multi-level hierarchy or single level of hierarchy? So that is also you have to design. If you don't design it properly, how the logic will flow and the controls will flow, and the state information sequence will flow. If you don't have thought through, it may again create an issue. Then about the infosec requirements, etc., you have to think through. And then these will lead to eventually a functional requirement. You will select the LLM. For example, LLM also you have to select based on your reasoning, level of reasoning required. If you are doing very high reasoning, you need to take some the models which are very good at reasoning. Similarly, you need to do framework selection. You need to select the layers, tooling, and guardrails with the non-functional requirements. So all this you need to select. This is very critical. These are again scalability best practices. So it is very important, like very easy to do 10, 20, 50 users or simple deployments. The moment you hit thousands of users or some scalable systems, you have to look at each level, platform level, pattern like selection of the patterns, For example, when you do agent level, like you need to know and you need to read through each of the frameworks, how many number of calls can handle, how many number of agents per account you are eligible. For example, AWS Bedrock only supports 100 agents per account, and it supports in the default configuration that you get, and it supports only 10 agents addition. So each framework have their own, limitations on how much agents they can do, how many interactions can be done, how much conversation can happen between, flow can happen between each agent to other agent. So you have to, I'm just put very simple 2-3 metrics, but there's a detailed metrics we need to think through when you're designing. Same thing for the tool level. So tool level, you have to think through what mechanisms to select, interruption features, asynchronous calling, because if you put a synchronous calling, again, we'll have a bandwidth, like it'll not be able to scale. Queue management, because if you are doing too many, if you have too many tasks flowing in, and if it's not thought through a queue management, the agent will overflow. Like the tooling, it is not completed, but the previous task is there, and some more calls need to be made. So you have to think through a queue management and incorporate that. These are not, you will not find in any of the standardized, you will see the content, but when you go practical, it will be very important to do that. So like how do you handle tool failures on the synchronization calls is a very important. And similar thing, model level also. Context window, token limit issue, how many tokens per minute you can do. So all these are very critical conditions, important things to handle. And same thing is with the memory management. So I think this may look like a spaghetti for you, but we are showing for, we've taken one example where like you are doing an agent assist type of scenario where like it like the chat bot, it is assisting on some user conversation, like the agents are assisting and giving answers for a client advisor on wealth management queries. But think through how we have designed the memory part, right? You have to think through procedure memory, you have to think through episodic memory, short-term memory. So you can see, I think I will not go through that, but short-term memory you will use, you will be using for context management. For long-term memory, episodic, procedural, semantic, this is all used for like a knowledge of the agent code and past experiences. It's just like if you have a past album, your episodic memory is like a past album. You have a photo album, and you want to go back and refer to that for what happened 1 year back, what we did, or a couple of weeks back. So this I'm taking very simple, but you need to think through and create your own diagram on how do you manage memory. And some very complex memory management, when you're doing scalable deployment, you have to plan this properly. And we have spent days on this. So it might think like a very simple topic, but eventually in some cases we have to look at open source and go there because it was giving only there we were getting options to customize it. Otherwise some frameworks were not giving option to customize. Without customizing, in some case studies, in some scenarios or some use cases, you will not be able to achieve the desired results. Okay, with this I'll hand it over to Anurag in the next section. Thank you.
So hello everyone, and thanks Puneet for this wonderful setting a tone for the session and providing such a great overview of the challenges in multi-agenting system. So be honest, is it just me or that who feels that we just learned how to deploy LLM application in production last year, and now this multi-agent comes into picture with new set of challenges to make our life more miserable? But it's not. Hello guys, my name is Anurag, and today we are going to talk on some of the key challenges that we face while developing this solution. And believe me, these are the ones that we handpicked for the presentation. Otherwise, talking on all the challenges we face will take a session on its own. So as an example, we take one of the solution that we built for our client. So using this is kind of supervisor, for those of you who don't know, this is sort of supervisor worker pattern where there will be set of agents and there will be one supervisor. So these agents will not collaborate to each other, rather there will be a supervisor who kind of orchestrate this collaboration between agent. Now we divided our challenges into mainly 3 categories. First category is basically managing supervisor at the start. The second category, which is kind of a most evil part of this entire flow, which is collaboration of agent. Now the third category is handling of the tools. So let's start with the first category, which is like a handling if the supervisor managing task properly or not. And there we want to, because supervisor task is most important. We have to, it has to ensure and assign, allocate tasks, delegate tasks properly across this entire agentic flow. Uh, Probably I will go over back and forth, discuss approaches on this thing, and we go again to make better understanding. Now, for making sure if our supervisor is able to allocate tasks properly, we found that asking agent to provide reasoning on why it is allocating tasks to this agent, not to this agent, is incredibly helpful. It provides some transparency and also provide like additional enhance basically this decision making. Additionally, including some dynamic few short examples along with some business logic really makes the deal for us and really improve supervisor flow there for us. Now, next come to part of like the most evil part, which I mentioned, collaboration issue with the collaboration of agent. There are mainly three challenges, like which we obviously all know that. One, because these agents are highly interdependent on each other. And let's say so we want to make sure that our response we are using is more structured. So the response which each agent is providing is much more restricted in terms of the way it provides structure, more structure. The other thing is like using the efficient memory, as Puneet already highlighted, that people usually take memory management very lightly, but it is very crucial to manage this so agent aware of like what's happening right now and simultaneously make appropriate decisioning. Now the third part is really always like, so in cases like when you see you want to regulate your collaboration of agent, is always try to prefer like a supervisor pattern. There are different pattern out there like reflection, supervisor workflow, and a lot of that, but prefer that supervisor one if you want to regulate your orchestration and collaboration between agent. Now I think the elephant in the room, which is the latency. Most of the client has faced that, like even some of the project that we build, because these LLMs uses underlying, so these agent using underlying LLM, which actually takes time to process your response and provide the answer. This will lead to the additional latency in you. And what works for us is like first started with your multi-region deployment nearest to your client location, like where you also want to serve your client. And also use kind of a API gateway to make sure you don't hit 2 token per minute limit. And the other aspect is to use caching as much as possible. I'm sorry. Wait. Now this is like about the agent collaboration. Now comes to tool management. So mostly like there are 2-3 issues with the tool management. We want to restrict tools into sensitive or unsensitive category. Like we want to restrict, let's say there are some processes, let's say in this example, we want to make sure like when wealth advisor agent responses, it doesn't responsive from someone else's account. It's only responsive to your account information only. So you have to put some identity management system to at a tool level also. So that is also very crucial. Now be honest, these tools handling can be prone to error. So we want to make sure whatever if they fails, we have to handle these scenarios also. So let's say there we are talking on some of the approaches we take, like in terms of like if it's like, and there is also other aspect in terms of agent part. Let's say you are building the reflection agent, right? You have one editor and researcher. And let's say you ask something, your agent to do some research on behalf and like ask editor to improve it. And your LLM missed to bring out some key information that you want to do. So putting some validation checks and some self-reflection prompt that actually helps you to ensure that it covers all the key information that you wanted to retrieve. And human intervention also could be a good proposal here to actually use these examples. Now the third challenge, like what if in case of tools fails? So it's always good to put some default responses to make sure, or alternative tools calling on something to ensure you handle this scenario. Now 8 challenges. is very important, and it only comes when you are running very unsynchronized call. And this is very unique, and we also did not thought of it initially, but we encounter one. And this challenge occur when, like, let's say, supervisor allocating tag asynchronously, and one agent is failed to retrieve answer first, and it kind of failed there, because it's missed out there. So enabling and building a separate queue to maintain like which agent retrieve first, which agent second, is highly crucial, because sometimes when you're running asynchronous call, you may miss out there. So it's always good to keep track using a queue so that you don't miss that calling thing. Now comes the part, like one of the crucial part in terms of evaluation. So I just want to raise one few raise of hand. Like, how many of you really pull your hairs and yell loudly on your AI agentic assistant when it provides you useless response? Okay, I thought it is just me. Uh, so yeah, obviously evaluating agentic, multi-agentic system can be complicated because there are a lot of component involved in it, right? So it's always best practice to dig dive into a individual component level, which is like if the supervisor is doing the right job, if the tool does not encounter error, and if it is taking right path, along with the end-to-end flow, like if the final answer is good, right? But there are so many metrics you out there. You can see there is final output we are checking, we are supervisor checking. So sometimes, developer faces problem like where to start debugging. Because that could be tricky because you are overwhelmed with these many metrics. Now how you don't know how to start. So we usually take this debugging approach that works out well for us. Feel free to share like if something works out well for you. So obviously first we start with see our end-to-end response is our final good, and if it is good, we yell out loudly that we did it, and if it's not, we go over to see if the supervisor is assigning right tags or not. And if it doesn't, then we try to fix it. And then we go over inside each individual agent if it is actually calling the right tool or not. And if it is, then it is good. Otherwise, we fix it. Now it try to go into if the tool is actually providing right response. If it is not failing, right, we try to check that. And if it doesn't, then again, we go fix it. Now, in the last part, we have done everything that we can in terms of optimizing our solution, but it's still not working. So now we have to rethink that the ground truth that we created is too complex to handle by this our existing solution in our current form or not. And we have to kind of recreate and our ground truth query or the answer of it. And that's how iteratively you try to debug and optimize your current flow. Now, in the earlier slide, we discussed at a high level like how debugging works, how this flow works, right? But how to build one from the scratch. So, because most of people like don't go on, first build the solution, then build the evaluation pipeline. But what we noticed, like it is always good to invest some initial time on building evaluation pipeline that enable to do iterative testing much faster than rather what you could do just not having a proper eval pipeline. So there are 3-step strategy that we took. The first one is obviously start with building ground truth data, right? But your ground truth data comprises actually everything that you want to evaluate. So at a high level, it should have like end-to-end evaluation, your input and your output. And your input should be there, and that trajectory, expected trajectory that LLM should take. And similarly, your each individual agent that you want to evaluate, like if it is calling the right tool or not. I feel free to take picture. I'm not going to speak over it and bore you with it. But yeah, at a full level, like we kind of have this end-to-end evaluation and corresponding metrics to it. And these are not fixed metrics. Feel free to, based on your domain, based on your use case, these metrics could vary. But so these are there. In terms of trajectory, we also have, and stepwise is basically their individual component. Now come to the last part, like when we define this middle strategy, now comes the last part. In last part, what people usually do is like they only test it with respect to ground truth, our performance, which could be a good parameter, good metrics for us to understand if it's working or not. But and kind of when you compare it with ground truth, chances that you may not get best performance, let's say 80, 90%, you may become hopeless. So it's always good to test with the previous run also. So that like if you are optimizing it with respect to previous run or also with respect to ground truth. And these kind of experiment that we can do. Now let's dig deeper, like on the individual level, like how to work on these things. Now comes to part where like how to build this ground truth data from the scratch, because this is also very tricky. I don't think any client or any stakeholder will have time, will willingly spend their time building their data for you, right? They are not paid enough to become a human annotator, and it's very costly. Believe me, it's very costly to hire one also. So in that case, what is recommend? We would recommend is like first start with very small set of ground truth questions. You already build one solution, be it like good enough. It should not be that well enough, but it should be working. Build your solution, and then take the responses, right? And take these different various responses. Let's say it should be, and then ask human to annotate just to rectify the ones which he feels are incorrect, and this way iteratively like improve and build your ground truth data from scratch. And this is like kind of step, always start small and use LLM as much as possible to build this data, so that your stakeholder should not feel like bombarded with the more extra work. Uh, so far we discussed about how to build evaluation pipeline from scratch, and also what's the benefit of it. And this is kind of a not this is kind of not that related to evaluation pipeline, but rather the underlying LLM that we are using there. And I think just one raise of hand, how many of you uses like LLM as a just to evaluate your model performance, be it like multi-agent or on the normal LLM application, LLM as a judge. So I guess like you can agree with some of the challenges which I mentioned here, that every time you run your LLM eval pipeline, you get a different response, or like your response varies a lot. And we took some of these approaches that works out well for us, and that made us like equal almost 85 to 90% similar LLM evaluation as similar as human annotator, like if human go on evaluating one. And this approach is not related to our strategy of agentic evaluation, but rather like how better we can approach this use LLM as a judge. So first is basically uses this framework, like instead of numeric number, rather use the binary thing. Feel free to build out your domain specific thing. And the most critical part, use the self-consistency approach. Like, ask 5 times and take the majority one. And these are few approaches which actually work out well. So now comes the lesson learned. And I'm not going to bore you with reading each one of these. So feel free to take pictures and read it later when you get time. But just to provide, I will become a chat GPT for you and provide a summary here. So the key summary is ground truth is good. You always build one, and never think that once you build this ground truth, never think it is static. Keep refining it because it's something which you have built, and keep refining as do this experiment and testing there. And the second is using LLM as a judge. Always do this iteratively because it may take some cost, but it definitely increase your development time way faster. So invest time in building evaluation pipeline there. So probably now, thanks a lot. I will hand over to Puneet on that.
Okay, I think this gets covered in the non-functional requirements, because when you're implementing any LLMs or agents, multi-agents, you definitely want to put guardrails, right? Because if you don't put guardrails, you're exposing your company resources, everything, right? And the input data to security risks. And most of the, if it's financial companies, they will have strict controls and risks, right? So you have to you have to manage those controls, and against the controls, you have to think through a mitigation plan. So if you look at, if it was single LLM, your only exposure is at one level, right? Because you're a single agent. One agent is multi-agent, and each agent is having tools, and the tools can call, say, serve API, or it can go to Google, or it can search internet, right? Because many places it is making external, internal calls. So there are multiple points of exposures in this whole multi-agentic systems. So you just need to, normally what happens in the LLM, you just put input-output controls, and you're done, right, at the level of the query level. But that approach will not work here, okay? You need to think holistically how the flow of information from one agent to other agent happening, at what points, what agent level, what tool level, you are calling internet, or you are accessing some external APIs or tools, which might bring in some risks. And that is where you have to put the guardrails. Okay, for example, this agent, execution agent, is going to call databases of web search. You need to put some, you need to first put a handover guardrails, and then you have to put guardrails at tool level also. Okay, you need to think through, even for the feedback, that at that level also you need to think through guardrails. So you have to think holistically on, when you're doing multi-agents, how the guardrails has to be designed. And this will not, you will not find it in booklet, but this, with the experience, you will know that at these stages it has to be put. Otherwise, I have not seen any articles telling at what level what should be put. They don't talk about just guardrails. Okay, and then the other thing is about monitoring, right? You have to monitor your multi-agents. Okay, so multi-agent monitoring is very critical. You have to monitor at system level, like what is the cost per task completion, what is latency, because the clients are going to measure you on the latency that you're doing, and they don't want in chat something, they put some question and it takes ages to come. So the latency is an important thing, cost is very important, and then your tokens usage is very common, right? But at agent level, how many steps each agent is taking, whether tasks are getting completed, they are getting failed, it is very important to track them. Similarly, what is success ratio, how much is the frequency of the API calls, error rates, all these are very important metrics you need to evaluate and you need to monitor, because then only you will know whether your agents or multi-agents are behaving properly or not. Then you have to, at a tool level, how much tools are failing, what execution time, are they not, so all that is important. Similar thing in the guardrail side, like prompt injection, loop detection, hallucinations. All this is important. Like, so each level you need to think through guardrails, and this is very high level covering, but it will be there. I think that's it. So if I need to just recap, last 1 minute. So when you're doing a productionization, you will have to think through holistically on multiple aspects, which includes your designing, security, guardrails, evaluation, right? And multiple other areas that you, like memory management. These are very important aspects. There might be more areas also, which I have not covered, but this will cover up probably 70–80% of the productionization considerations. Thank you all from our side. I think we are done. Thank you.
Yeah, we are happy to take questions if anyone. Yeah, please.
Yeah.
You talked about the ground truth, right? And you're saying that work on it, but any best practices to prepare the ground truth? Because that's the point where the whole crux is, like.
I'm sorry?
Ground preparation.
Truth, the ground truth, you talked about it, right?
Yeah,
Like
yeah.
the slide. So any best practices to
Any best practices for ground truth preparation?
for the ground truth, because that's the place where example,
Can you,
not with the multi-agent flow, maybe something,
Yeah,
let's
yeah,
say my agent is about, so something on the, let's say on the anomaly side of the house, you have very rare data.
Yeah.
Something like with the combinations of flows in our agents. Humans cannot think about all those areas,
Yeah,
right?
absolutely.
So how you will prepare the ground truth, right?
Yeah, so actually that's where I talk about like using existing solution that you build, like your first draft, to generate these answers. So that actually helps us to build your initial draft and gives you a better picture, and then maybe ask, then we, like, sometimes what happens, like let's say for example, I'm taking this simple example, like this example, let's say I'm working in a branch, banking branch, and there are lots of documents. I only know some handful document that can serve this user customer query. But there are other documents which also talk about this, right? If a user asks a question, my LLM does not pick the one which I know, rather pick some other documents, right? Now I get to know, okay, these are other also documents that helps to answer, and I'm using this first draft of the answer provided by our solution to user, and later he will annotate it. So it will expedite the process of creating your ground truth from the scratch, and also take account of already existing document that you have, the knowledge that you use to build your first solution there. if it makes sense.
Yeah, so, but again, the documents you give an example on banking, but getting into a label data structure is a
Yeah,
tedious
yes, I
activity,
definitely
right?
agree. And we are using a lot of iterative process. Like after once we build our solution, right? We are using some back office tool where like user uses like manually annotate these data completely, and it's kind of combination of like using existing solution plus human annotator to build your data. And I agree, like it takes time to build one,
I
definitely.
mean, this is advice is use synthetic data plus human, mix them both, and use LLM as a judge whenever you like. I mean, like as a both augmented data for your ground truth, because just getting the ground truth maybe from the client may not be sufficient, right? And they may not be able to do that.
Yeah, maybe
That-
we can talk offline to
Absolutely.
discuss in
Thank you
detail.
so much.
Yeah,
Thank you.
yeah. Because it's not that like easy to
Okay.
explain.
Any other questions quickly? I think we have
Yeah.
But
limited
we can
time.
talk offline.
Hey,
Yeah, there's one
Puneet.
question there.
Yeah, sure.
Hi, Puneet.
Let's
Hi,
quickly
Anurag.
cover. Yeah.
So
We have 4 minutes
thanks.
left.
It was very detailed information on agentic patterns, actually, the deployments and everything. So I just want to ask, whenever we implement all these approaches which you have just mentioned here, the very basic challenge we face is that prompts gets bigger, right, for each agents.
Right.
And maybe number of agents also increases whenever you follow some particular agentic pattern, right? Let's say you divide some task into multiple agents. So with these approaches, the chances are that your latency will increase in multiple
Definitely
folds,
increase. I
right?
mean, if you have say 7 agents in the pipeline and series in the series are 3 agents, each agent is taking 3-4 minutes, then you put a question, might take 9 minutes to come back response, which is not acceptable in many cases, right?
Right.
So that
Right.
will definitely be there. And that's what he was saying, that you'll have to holistically look at each step by step, where you can do parallelization, where you can do caching, where you can, the tree that you are creating one after one, how can you shorten that, make it flatten more? You know, if the latency is your challenge and that is a priority, then you have to design according to that. And also, if you have a lesser tree, less than flat tree, your context will also get better maintained. And you might end up having 2 different systems and combine them together also. You have to think through innovatively. Because if you don't think
So
through...
is there something you guys did on deployment side, that how would you deploy your agents in microservices fashion so that they scale well at least?
Yeah. So when you deploy the microservices, you will have to look at the transactions. The transaction are translating to how many tool calling, how many average higher side, how many agents are getting called, what frequency, how many APIs are getting called. All that you need to think through and see and put an adequate, like in the PaaS mode. If you're doing a PaaS, you have to, they need to provision those services accordingly. Like whatever, and you need, if they are, most of the cloud providers give you committed offerings, which will help you reduce latency. Otherwise, you can do a Docker deployment, and on your own you can do that. And other thing is that I mean, these things are very important.
Thanks a lot. Thanks a lot, Puneet. It was a very good presentation. Yeah.
Thank you. Thank you.
So what, Renee?
Do we have any more questions?
Yeah, I think one last
We can
question.
take
Yeah.
last one.
Yeah.
Yeah, thanks Anurag, thanks Puneet for your wonderful session. And I do have some experience in working with this agent AI and deploying this. One of the challenges currently we are sitting on is number of API requests that you have highlighted in your last and the
Right.
context window,
Right.
So how you're tackling, I mean, we have the limit up to 50 users or 100 users, probably we could able to manage it. However, if things are going beyond, like we want to scale it from 100 to 500 users, then number of API requests, it becoming challenging for us. Then what is your perspective? How we are going to solve it and how you are solving in your production?
I think there are 2 things, right? When you are making number of calls are happening, your tokens per limit, right? Tokens for LLMs will increase because you are making more calls, and most of the LLMs, whether it's OpenAI or they will put their limit on how many, TP, like tokens per minute you can call. They will time out, right? So the option is that you
Yes.
put a load balancers, and you can, load balance them across. You need to fork out your LLMs across regions, which are nearby regions, and then you need to put them in the load balancing. That is the easy way to do that. But Microsoft or others also, providers give you TPUs, something called as PTU, committed, LLM tokens per minute, which you have to, as an enterprise level, you have to go and talk to them, and they will give you based on the capacity you need. You can take that because that will significantly help you in issues, solving these issues of number of API calls and LLMs not getting time out or not getting tokens, right? Those issues can be solved by using that approach, either by load balancing or by using the other one. The context window problem is different. Context, if you are exceeding context window, if you're putting very large text, it's not getting, and you're not able to pass everything into one go to LLM because the context window is limited. Then between the different calls, if you're splitting the text, you need to pass the context yourself.
Chunking, yeah.
Sorry?
Chunking basically,
Chunking. So when you're chunking, so between the chunks, if they're logically linked, you need to summarize them, or pass the context between those different calls if you think that things are together, right? So that is how you need to solve it. So there are methods to do that, where you pass some additional context with each chunks, and if they're linked together, and that is where you can solve those. It might, and give references, and you summarize each of the chunk, and that you pass it the next chunk, so that it has a summary of the previous chunk. Something like that can also help. There are many strategies. This is talking about one strategy.
Thank you very much,
Yeah.
Anurag. Thank you very much.
Thank you. Thank you.
Thank you so much. If you have any questions.
Yeah, feel free to connect offline. Yeah, I understand. Thank you.
All right. Thank you, Anurag.
Thank you. Thank you,
and
everyone.
Puneet, for that wonderful, insightful, and detailed session.